So, so just a few reminders. The web work will be due on April 27th, Monday, and then final exam will be on Tuesday. And I say in my email that it's only 3 hours, but it's actually 4 hours. So it'll be available all day on Tuesday, but the time limit is 4 hours. I've also prepared a review checklist, and you can find that on Piazza, or you can check the email that I sent out yesterday. They say there's a bunch of practice questions that you can find on D2L. So those are very similar that what we will see in the final exam. Um, and then you also have a quiz, the last quiz, quiz 12, that's due this coming Sunday. Any questions? No. Okay, so I'm gonna do the same thing as what we did for the reviews previously. So I want you guys to take 5 minutes to look at the review checklist, and then we'll come back in 5 minutes and make guesses what kind of questions that we expect to see in the final exam. So yeah, go ahead and look at the review checklist. We'll be back in 5. All right, so from the 7-page review checklist that I prepare, do you guys have any questions or um, I guess I should say so yeah, yeah, okay, so we'll start making guesses what sort of what kind of questions that we'll get in the exam. So go ahead and make your guesses. Okay, definite integrals. Okay. So in the standard exams, you usually get 2 or 3 integrals. They could be definite. They could also be indefinite. Maybe I should just. So as I say, in the standard exams, they always have 2 or 3 questions on integrals, and then one of them you definitely get at least one of them that would need to do some U substitution. So at least one question on U sub. Anything else? Yep. So the very first topics that we did was limits, and I will actually do 2 limit questions today. What else? Yeah, area between 2 curves. Radial change. What do you mean by radial change? Do you mean the AROC, the average radial change? Or do you mean I mean, I know that the rate of change, average rate of change, instantaneous rate of change, are one of the very first things that we did in the beginning. But at least for final exam, it won't be as important as other stuff. Limit definition of derivatives. So that's something you want to look at again. Yeah, implicit differentiation, that's a good one. What else? Well, so another thing is when we did the review, yep, derivatives, all kinds of derivatives. Just as so similar to definite and indefinite integrals, they are always at least 3 questions asking you to compute the derivatives. So chain rule, product rule, quotient rule. What else? Derivatives of trig functions, sine, cosine, tangent, cotangent, secant, cosecant. What else? Oh, I was gonna say, so another thing we so when we were discussing exam two, so I think I mentioned that there was a big question. There was gonna be a big question asking you to compute local extreme, um, local max, local min, inflection points, concave up, concave down, increasing, decreasing, and stuff. I think you will get that again in the final exam. I don't even know what to say there. So local extrema, inflection points, graphing. What else? No? Okay. I guess we can start doing some questions. Uh-oh. I'll be back in a second. So this is the final exam from spring semester 2018. And I want to start by doing two limit questions. So let's look at question 1A. So I want to compute the limit of x squared minus 4 divided by x squared minus 2x. What do I do? So what's the first thing that comes into your mind when we're doing when I'm doing limit questions? So how would you go about this question? Yeah. So for the top, x squared minus 4, how do I factor that? So x squared plus 2 is x plus 2 times x minus 2. What about the bottom? What about the denominator? So x squared minus 2x. How can I factor that? Yep, so you put an x out, you get x times x minus 2. Is it okay so far? And the only reason I'm doing this is because when you plug into the original function, the denominator becomes 0. So that's why you need to factor and see that if there's any cancellation that you can do. And once you do the factorization, you see that x minus 2 on top and x minus 2 at the bottom cancel out. And so you get x plus 2 divided by x. Now the final step is, what is the limit of x plus 2 divided by x when x approaches 2? Yep, so just plug in the 2. So 4 divided by 2, which is 2. Is it okay? Any questions? Let's do part B. So I have the limit of x minus 4 times x plus 2 divided by x minus 3. We want to compute the limit as x goes to 3. Any ideas? So first of all, is there any factorization or cancellation that we can do? Okay, so yeah, so there's no cancellation that you can do. The best thing you can do is you can compute the left-sided limit and the right-sided limit. Oh, and the reason I know that I need to approach from the left and right is because if there's if there's no cancellation that you can do, and if you notice that when you plug in 3, the denominator becomes 0, that means you would expect your limit value to be one of the following. So it could be positive infinity, negative infinity, or it doesn't exist. How do I check it exists or not? You need to check the limit from the left and from the right um, agree to each other. So let's do coming from the left. So if you're coming from the left, um, is it positive infinity or negative infinity? So pick a number. So if when you pick a number slightly smaller than 3, x minus 4, is it positive or negative? X minus 4 is negative. X plus 2 is positive. So this one negative, this one positive. What about x minus 3? Well, you're picking a number smaller than 3, and then I'm asking what is x minus? Yep, x minus 3 should be negative. So negative, positive, negative. So this one should be positive infinity. Does it make sense? Do the same trick to the second, to the right limit. This one will be minus. Sorry, this one will be negative. This one will be positive. But this time, if you're picking a number slightly bigger than 3, x minus 3 should be positive. So negative, positive, positive, that gives you negative infinity. Are they the same? They are not the same. So you say that the limit does not exist. Questions? Okay. Moving on. I think most of you probably don't remember this. So question 2, given the function f of x equals 1 over x plus 3, calculate f prime using the definition of derivative. So what was the limit definition of the derivative? Recall that the limit definition of the derivative was this guy. Yeah, so that means I need to compute f of x plus h. So f of x, so in the question, f of x was 1 over x plus 3, which means f of x plus h is, so how do I compute f of x plus h? You just replace, yeah, you just replace the x by x plus h. Is it okay so far? And so the derivative of 1 over x plus 3 by using the formula, I get this. By the way, if you're thinking that because this is because you only get multiple choice questions, so I don't need to know the limit definition of derivative, you are wrong. I just saw a question on the practice exam that there's a series of questions asking you how to do the limit definition of the derivative step by step. So you actually need to know what is the definition, and you need to know what techniques to use when computing the limit like this. So yeah. So what do I do after this? What is the next step? Mm-hmm. Yeah, so what I can do is I can multiply the top and bottom by x plus h plus 3, as well as x plus 3. So multiply x plus h plus 3 times x plus 3. The same for the bottom. And so you multiply both terms. So for the top, 1 over x plus h plus 3 times x plus h plus 3 becomes x plus 3. The second term, if you simplify that, you get x plus h plus 3. Is it okay? Questions? And then x, this x cancel out with this one, the 3 cancel out with the other 3. And so for the top, you end up with negative h. For the bottom, you have x plus h plus 3 and x plus 3. What do I do next? So it should be easy from here. What do I do next? You cancel out the h. Once you cancel out the h, you can put h equals 0 right away. And so you get negative 1 divided by x plus 3 times x plus 3, which is the same as negative x plus 3 squared. Is that okay? Um, and it should be the same as how you compute the derivative by using either the quotient rule or the power rule or any rules, right? It should be the same. I'll let you check that. Any questions before we move on? No? Okay. Still have time, so let's do this. Question 3, part A. So given the function 3x squared times secant of x, find the derivative. So what rules do I use? Chain rule or product rule? We'll see. I mean, definitely product rule, but I'm not seeing chain rule. So you're right that this is a product of two functions. So the first function is 3x squared. The second function is secant of x. And so by product rule, product rule says that I need to take the derivative of the first term times the second term plus the derivative of the second term multiplied back by the first term. Is it okay? Now, what is the derivative of 3x squared? 6x. So 6x. So the first term is just 6x times secant of x. Second term, what is the derivative of secant of x? No. No. Secant of x, tangent of x. Is it okay? I should also mention that this is a good time to confuse yourself about derivative and antiderivative. The derivative of secant of x is secant of x, tangent of x. Um, um, but antiderivative is something else. Anyway, so we have to be careful about what the question is asking. So make sure you know what's the difference between the derivatives and antiderivatives, especially for for trigonometric functions. And any questions about this problem? No? Okay, next part. So given g of x equals x plus sine of x cubed, find the derivative. So what rules, in this case, what rules do I need to use? Chain rule. And to use chain rule, you need to identify which one is the outer function, which one is the inner function. So what is the outer function? So this thing, cube, that's the outer function. And whatever that's inside, that's your inner function. So chain rule says that I need to first take the derivative of the outer function. So what is the derivative of something cube? So 3 times something, and then 3 minus 1, so square. And then that's something that you have to put is the inner function. So put whatever that's inside here times chain rule says that I also need to multiply by the derivative of whatever that's left over. So I need to multiply by the derivative of the inner function. And what is the derivative of x plus sine of x? Yep, the derivative of x is 1. The derivative of sine of x is cosine of x. That's it. Questions? No? All right, let's look at this question, question 5, part A. So I want to compute the integral of secant square of x minus 5 times the cube root of x squared plus 1 over x squared. Yep. So I can find. Okay. So what is a when it comes to computing integrals? What do I need to do? I know the first thing you want to separate the integrals into 3 parts in this case. But what is the next thing? I'm asking. So for example, how do I compute the integral of secant square of x? Yeah. So remember that integral is the same as taking the antiderivative. So But before doing that, let's try to simplify um, everything inside the. So back is good, but the second function I don't like it. So how do I rewrite that? It's 5 times the cube root of x squared. So this one is the same as 5 times yep, x to the 2/3. And the last thing, it's 1 over x squared. 1 over x squared is the same as x to the negative second. And from here, you take the antiderivative. So what is the antiderivative of secant square of x? So it should be easy. Tangent of x. What is the antiderivative of 5 times x to the 2/3? It's 5 times it's 5 times x to the 5/3 divided by 5/3 plus what is the antiderivative of x to the negative second? So using the same power rule, you have x to the negative 1 divided by negative 1. Am I done yet? I forget something? Did I forget anything? Mm-hmm. Plus c. Don't forget plus c. Any questions about this problem before we move on? Okay. Next part. So how do I compute the integral of x to the 4 divided by the square root of 3 plus 2x to the 5th? You do u sub, and what do I use for my u function? Yep. So you pick u to be 3 plus 2x to the 5th. Just want to remind you, so what is the, how do you pick the u function in general? How do you know that's a good choice or not? Yeah, so usually the u function is inside another function like the square root. The second situation could be it's in the denominator. The last, the next situation is when you take the derivative of that u function, it shows up somewhere in the integral. In this case, you can see right away that when I take the derivative of this 3 plus 2x to the fifth, I get something that looks like x to the 4, and it's inside the integral. So that makes um, this is good pick. So the next step is I want to compute the derivative. What is the derivative of 3 plus 2x to the fifth? What is the derivative of 3 plus 2x to the fifth? Yep, 10x to the 4. And remember that the goal of using u sub is to replace all the x by u and to simplify the problem. So I need to replace everything by u and also du. And from du dx equals 10 to the x to the 4, I know that du equals 10 times x to the 4 dx. And x to the 4 times dx shows up here. So let's divide both sides by 10. And I get that du dx, I get that x to the 4 times dx. That's the same as du divided by 10. Is it okay so far? Next step, rewrite your integral in terms of u. Again, x to the 4 times dx. That's something I know. That's du divided by 10. And for the bottom, I have the square root of 3 plus 2x to the fifth. But from my definition of the u function, 3 plus 2x to the fifth is u. So this is the same as root u. Is it okay? So the problem simplifies to taking the antiderivative of 1 over root u, right? Because this is the same as 1 over 10 times 1 over root u times du. And doing the integral is the same as taking the antiderivative. But before doing that, I don't like 1 over root u, so I rewrite that as u to the, what is 1 over root u? It's u to the, it's negative 1/2. And we all know how to compute the antiderivative of u to the negative 1/2. This is u to the, you're taking the derivative, so the exponent goes up. 1/2 plus 1 divided by 1/2 plus 1. Don't forget plus c. Am I done yet? Okay, so put your u function back in. U was 3 plus 2x to the fifth, so put that back in. What was it again? plus C. And that's it. Is it okay? All right. I think that's the only thing that I want to do today. But 1 second. Once again, don't forget your homework, and don't forget to do the practice questions on the E2L. And if you have any questions, feel free to send me an email. Otherwise, good luck for everyone.